Hey, and welcome back to another tutorial. And in this tutorial, we're going to take a look at an easy way to download JSON using MVVM in our SwiftUI apps. So once we've actually finished that, we'll then look at how we can actually handle errors as well within our apps. Before we actually look into our example, what I wanted to show you is the API that we'll be working with in this tutorial. So this API is called JSON Placeholder, and I've already got it open on my browser here. So this is just a dummy API that you can use to just quickly, test out your networking code if you wanted to. And if we just scroll down, the endpoint that we're going to be using is the user's endpoint. So this one here. So if you actually click on this, you should actually see the response that you get back from the service when you actually tap on users. So what we want to do is we actually want to copy this model within our SwiftUI app. So in this example, the only properties that we're going to be using from this model is the name, email, and the company as well. And for good measure as well, we'll also add in the ID. So let's just do that now. Now, in order to create this, I'm actually going to create a new codable object in our project so we can mimic this model. And I'm going to type this out and then we'll break it down. Okay, cool. So this is the model in our SwiftUI app. So this is what we're going to use to model our data onto the UI. So you may be wondering, if you've never saw this before, what is codable? Well, codable is an object that actually allows us to convert and map our JSON to our Swift models. Or if we wanted to, we could do the opposite and we can actually turn our Swift models into JSON in order to interact with an API. So in our case, what we want to do is we actually want to convert the response that we get back from the service into our user model so that we can interact with it. So what we want to do is actually match the structure of this response within this codable struct. So like I said before, we're going to copy and use some properties from within the response we saw on this screen. So let's just work through these one by one. So the first thing that we want in our user model from the API is an ID. So when you're actually adding in the property within your codable object, there's two things you need to make sure. The first thing is, unless you want to customize the way that the property is named within your model, which we're not going to cover in this video, but we will in a future video, you need to make sure that the property matches the exact same name within your model and as well as the type. So in this case, we want to add in the ID, and since this is a number 1, it's not a string because we don't have the quotation, we want that to be an int. So let's do that now. Okay, cool. So now we're saying here within our user that I want to access and I want you to map the ID from the response to the ID in this user. So let's move on to our next one, which is going to be our email and our name. So let's just add in name first. And this is type string because if you look at our response, it's covered. If you look at our response, it actually is wrapped around the quotation mark, so it's a string. And the next thing that we want to use is the email. Okay, cool. So our struct is marked with codable, meaning that we can actually now automatically map the response that we get back from the service to this model. Our properties within our model, so ID, name, and email, matches the exact same spelling and casing as our response as well. Cool. So we wanted to add in the company as well. If you look at company, it's actually its own object. So how do we handle something like this? Because we can't define a type straight away called company. It doesn't exist. In order to do this, what we need to do is we need to create another object called company and then assign a property that type. So we want to copy the structure within company. Now within this, I'm only going to worry about the name just to keep it simple. So let's go into our file here and then we'll create a new struct called company. And then as usual, make sure that it's codable. And then, like I said before, we want to use the name, which is of type string, like so. So in order to actually use this company within our user, we need to create a new property within it. And like I said before, we just want to use company. And then we want the type to be our new struct company, like so. So now this matches the model that we have within our JSON response. So now that we actually have our model, one thing to note here is that all of our model properties are constant. So these are immutable structs. Since we don't actually want to allow someone to change and modify this, we want to reflect what we get back from the service. So your model should just reflect the data that you'll be getting back from the service, and that's it. So it should be dumb and not know anything about the business logic. So the next thing we'll do is actually build our view model, which is what we'll use to actually execute this request. Now let's do this by creating a new file called users view model. Now, within this file, what we want to do is actually write our business logic to actually handle fetching the users from our API. So we want to create a function that calls and interacts with this API. So let's call this fetch users. So the next thing that we want to do within our view model is actually declare the URL that we want to use to fetch our data from, which is the API that we declared before. So let's do that now. Now it's worth noting that I'm just keeping this very simple. Normally, I wouldn't just directly put the strings within the actual function, but just to showcase a simple example of MVVM with a network request to get something up and running quick, this is fine. So let's do that now. So what we have here is the URL that we have that we want to interact with. So this is the API. So if you actually look at this URL here and compare it with what we're interacting with, you'll see that they're both the same. So when we make the network request to get this data, this is what will be in our response back to us. Then what we do is we actually convert this string into a URL object so that we can use this to actually execute a network request. Next, we'll use the URLSession framework to actually execute and call our API. So let's actually write this out first and then I'll break it down. So what we're doing here is because when you construct a URL, it's actually possible that it could be invalid. So what we need to do is we actually need to safely unwrap the URL so that we can access it and make sure that we're not trying to use a nil object. Then after we finish doing that, we actually use the URLSession framework to actually handle executing a network request. So what this is doing is it's actually using the shared instance, which is a singleton, and then we pass it the URL and then we tell it to actually start the process to execute this URL so that we get a response back from the service. So when we get a response back from the service, we'll actually get that within this closure here. And what this will return to us is the data, which is the data that we've got back from the service. So that will actually represent all of this that you see on the screen here. We also get back the response. So if we want to actually inspect what we got back from the response, such as the status code, or if something went wrong, or if something was being sent to a specific endpoint, we can do that here. And then finally, we also get an error. So this will actually tell us if when it tried to execute the request, if something went wrong, and we can access all of that within our closure. And if you want to learn more about closures, then check out my video, Communicate Between Views Using Closures. Now, when you work with URLSession like this, there's one last step that you need to make sure that you add in, which is super important. Right now, what we've wrote won't actually work in terms of executing the request. And the reason why that is because we need to call a function to actually start the execution. So let's do this now. So at the end of your closure here for the data task, you actually want to call a function called resume. And what this does is it actually starts the task and actually executes it for you so you can actually handle the response within the closure. So now within our URLSession, we need to actually handle our data that we get back from our service. So we can actually handle this by using something called a JSON decoder. And I'm going to type this out and then we'll break it down. In our closure, what we have now is we're unwrapping the error if there is one. So if the error object is not nil, then we're going to handle any errors within this case. And we'll get back to this in a second. The next thing that we do as well is we actually create this new object here called a JSON decoder. Now, if you've never saw this before, what this essentially means is that it allows you to use the decoder to convert data, so a data object, into a object that conforms to decodable. So in our case, if we just go back to our model, it doesn't conform to decodable explicitly, but by conforming to codable, if I just click into it, you actually get decodable and encodable for free. So this is just a way to get both of the capabilities for free without having to specify decodable. 9 times out of 10, just to be safe, I always use codable rather than specifying decodable or just encodable. So what this will do, it'll actually try to convert our data that we get back from the service to the model that we've created and marked as codable if the properties that we've defined within them match. And I've just added this thing here called a key decoding strategy, convert from snake case. So what this will do is if in the API you had a property like this where it was like underscores, what it'll do is it'll actually automatically convert that into camel casing for you. So this is something that I just add in as a habit because I don't know if the API might add this in by accident. And if it does add it in, then my app kind of covers and handles this snake casing for me. Now we need to actually finish off our JSON key decoder and we need to map it to a type that we're expecting back from the API. And if we all go back to our page, you'll actually notice that we don't just have one user, we actually have a collection of users because you can see here there's 1, 2, 3, 4. Well, there's actually 10 users on the screen here. So we can't actually say to our decoder that we just want one single user. We actually want a collection of users because there's more than one. So we're expecting an array of users back from our API. So I'm going to type this out and then we'll break it down. What we're saying now after our JSON decoder is we're actually going to safely unwrap the data. So if the data is nil, then it's going to fail in this condition that we've got. So we want to make sure that we can safely unwrap the data. After we finish doing that, we then want to use the decoder to try to decode our data to this type. So like I said before, we want a collection of users. So we want to decode it to an array of users. So now we have an array of users within this constant, and we can actually handle using our data that's been converted from data to our model within this view model here. So this is our business logic for handling fetching users, converting it from the service, and then returning it to our application within the view, which we'll handle later. Now that we have this, we need to actually use our users and store it in something for our view to listen to. Now in our file, we're going to create a publish property for our view to listen to once our business logic completes. So let's actually add this in now. In our view model, this is our source of truth. What do I mean by that? Well, the source of truth in this case essentially is just the property that our view will listen to in order for it to react to those changes. So what we want to do is we want to actually show a list of users on our screen. So this is the source of truth where our view can listen to those changes. Now what I have done is I've actually marked this as an empty array of users because when you actually load up the app for the first time, there isn't actually going to be any users. It's only until we execute our network request we'll then set this with the users that our function has tried to decode. So now let's actually use this source of truth and actually set it within our closure after everything has been successfully decoded and it's all good. So let's do that now. So now we have our users being set. Now in this case, we actually could have a potential problem here where we have something called a retain cycle, which means that our object, which is our user's view model, won't actually be removed when the system tries to get rid of it. So in order to avoid this issue, what we need to do is actually set our closure to be weak. So let's do that now. Cool. And because of that, we'll actually get an error now because we've made this weak. That means that all the objects within this class are actually optional now within this closure. So in order to fix that, all we need to do is just add in the question mark like so. Perfect. Now that we've actually handled that and used it in our view, we'll actually come back to this file to handle errors, but let's just see our users within our app. So now that you saw how we set up our model, which like I said before is just our dummy file for handling our data, we've now set up our view model, which is what we use for our business logic in order to actually fetch and retrieve a user. The next thing that we need to do is actually hook this up. So we want to hook up our business logic to our view so we can see a list of our users. Now let's go into our view, and what we want to do now is actually tell it to use our view model to help us fetch that data. But before we actually fetch the data for our users in our content view, let's just add in some basic UI so we can actually just see this on the screen first. Rather than me just directly adding in the view within this content view, I'm actually going to break this out into its own specific component called users view. So this is the view that we will be using for displaying the user's name, email, and their company information. And I just put placeholders so you can easily see this. So what we want to do is we actually want to use this view within our main app so that when we get a response back from our service, we show a collection of these views. So just to see what this would look like in a list, I'm just going to add in just one user view within our content. So I'm just going to type this out and then we'll break it down. Now that we've added this in, we've just simply got a list within a navigation view, and we set the style of the list to plain, and we also remove the separators on our view within our list. Now if you want to learn more about lists, then you can check out my video, List for Beginners in SwiftUI. So now we've got our UI in place, what I like to do now is we need to actually create the link between our view and our view model. So let's do that now. So now we have a state object instance within our user's view model. Now you don't really want to use observed object here, and the reason why you don't want to use that is because it's actually possible for your data to get reset every time this view's source of truth forces it to re-render. And you can actually learn more about state objects as well within my video, state object in SwiftUI. So we actually want to use this state object now to actually listen to our users and pass that user into this view so you can see it on the screen here. So in order to do that, what we want to do is we need to use a for each loop to loop through all of the users that we get back from our API response. So in our list, let's just create a for each. And then this for each is going to be based on the viewModel.users, like so. And then this is going to give us back a user in. And then we want to pass that user into this user view. But if you actually build this project, you should notice that you actually get an error. And the reason why we get this error is because it's actually telling us that it requires, for each actually requires our user model to conform to identifiable. Now there's two ways to get around this. The first way is by simply conforming to identifiable on our user, like so. So now what this will do is it will actually use our ID property that we specified here as the identifier, because with identifiable it actually adds in a property called ID, so you can specify what is the ID for this user. Now that we've removed that, you can see that our error has gone away, like so. But if you're someone who doesn't want to use the identifiable protocol because you just don't really need it, what you are able to do on your for each is you're actually able to specify using key paths what property you want the for each to use to identify each individual object. So we can do that by using the ID that we specify within our model. So let's do that now. And now you'll notice our error goes away because we're actually telling it to use the ID as the unique identifier for each user within the collection. Now what we want to do is inject our user within this user view. So let's go into our user view and then let's create a new constant here called user, and it's going to be of type user, like so. And then we should have an error in our previews because it's expecting us to inject a user. So let's just do an init here. And then we're just going to put in any old information. So now what we want to do is we want to use the actual properties from within our user within our VStack here. So let's do that now. So now we're actually using the properties that we want from our model within our user view. So we should have an error here. And the reason why we have this error is because we go back to our for each. It's actually telling us that you need to pass in a user here. So let's do that now. So we pass in this user like so, we shouldn't really get this error anymore. Okay, cool. So now the last thing that we need to do is actually call our function to actually show our users on the screen. Now me personally, I prefer to actually wrap my views within a Z-stack. And the reason why that is because when I'm actually interacting with an API, I actually like to give the user some kind of feedback that something is going on. What we're going to do is wrap our list within a Z-stack, like so. And on this Z-stack, we're going to say, when it appears onto the screen, I want you to execute the function to fetch users. Cool. So now this will actually call our function from our view model and actually start off the process of fetching users and showing them on our screen. So our for each here will actually update when our users array within our view model updates as well. So let's do that now. So let's run this on the preview and just see what happens. And as you can see, it's quite quick. We can now see that all this data is coming back from the service. Now, this is great and all, and it does look like everything is working fine. But if we actually run this on the simulator, we've run this on our simulator and everything looks great and it looks fine. But one thing to notice is that if you actually go into your user's view model, you'll see that you actually have this purple line here. So what is this? Well, when you actually execute a network request, it's actually executing it on a thread that isn't the main thread, because we don't want to do stuff on the main thread when we call a network API, because that will freeze the whole app. So what happens is it executes that request on a thread that is a background thread, but the response that you also get back as well isn't on the main thread. So what we need to do is we need to actually tell our code within our data task closure to execute itself on the main thread. So how do we do that? Well, we just want to wrap everything within our response from our data task within a dispatch queue onto that main thread. So let's do that now. So let's delete this. And we're going to type out dispatch queue.main.async. And then within this async here, we want to copy all of this. I should say cut. And then we want to paste that within here. So now this will make sure that the response that we get back and updating our UI will be on the main thread. So let's run this again now and see what happens. And as you can see, we don't have that warning anymore because we're now doing the right thing by updating our UI on that main thread. So the next thing I want to look at is how we can actually handle errors within our app. So let's say if we actually pass in an invalid URL, or there was no internet connection. Right now, nothing is going to happen. I'll give our user any feedback that something has gone wrong. So first of all, what we need to do is actually create an error for our users using the localized error type. So let's scroll down to the bottom of our user's view model, and I'm just going to do some typing and then we'll break it down. So what we have in here in our user's view model is we have the enum user error, and we've said that we want this error to be of type localized error. So the reason why we have this type here is because it allows us to actually customize the error description, the recovery, and suggestion as well. So you can actually give your user custom suggestions for an error. And then we have two cases within this enum called custom, which allows us to pass in a custom error. And the other case we have here is failed to decode. So these are those errors that we're going to throw. And then when we get a value back for either one of these two cases, we're going to show either one of these two messages like so. Now we actually need something in our view model to tell our view when an error has occurred. So in order to achieve this, let's actually create two properties, one for telling our UI that there's been an error and another for holding the actual error so we can show that on the screen. So if we scroll up, underneath here where we have our empty users, we're going to do a bit of typing. Okay, cool. So now within our view model, we have a property that tells our view whether an error has occurred, and we also have a property in here that holds the error if something went wrong. So we're going to set this in our paths where something can go wrong. Cool. Now that we have this in place, we need to actually handle the case paths where the error could go wrong. So whenever someone actually starts and fetches a user, we want to make sure that the has error is always set to false. So let's do that first. The reason why we want this to always be set to false when you call this function initially is because you just started the process to fetch a user. Nothing's actually gone wrong yet. So we just want to always reset the state of this back to false. Then what we want to do is that if an error has occurred, so inside of this if let, we want to make sure that we actually set has error to true, and we also want to set the error published property to be the custom error with whatever went wrong. So let's do that now. So if there is an error and we successfully unwrap this, then we're going to set has error to true, and we're also going to set the error property within our publish property in this view model to be a custom error with whatever went wrong from URLSession. Now the next error that we need to handle is if something goes wrong when we're trying to decode our user. So we're trying to map the response back to our model. So let's do that now. So now we have our other case path here where we set the error to true, And we also set the user error to it failed to decode. So now we have this in place. What we actually want to do is if any of these has errors is set to true, we want to show an alert on our screen. So in order to learn more about alerts as well, you can watch my video called Alerts in SwiftUI. So let's actually add in an alert onto our view. So if we go into our content view, on our list, I'm just going to add some code in and we'll break it down. So on our list, what we're saying here is we're using the alert modifier to check if it should be presented based on our has error. So if this property within our view model is set to true, then it'll actually show our error on the screen, and it will also use the error message from the error description that we described to show that within the alert as well. And then all we've done here is we just added a button where we can simply just retry it. So in order to actually see this in action, let's actually mess up our URL on purpose. So rather than this being users, we're just going to put an X on the end of this. So if we run this on the simulator, you should notice that you now can see your error on the screen. If you hit retry, it will try and fetch it again. And because it fails, because it's still the wrong URL, it will just keep on failing. But we get user feedback that something has gone wrong. Now, it would be nice if when you hit retry, if it takes a long time, you get some kind of spinner to tell you that something is going wrong. Well, we can actually do this by adding in another property within our view model called isRefreshing. And what this will do is it will actually allow us to listen to the changes as to whether we're fetching data or not. So this is simply a Boolean, as you can see here, and isRefreshing can only be either true or false. Now the reason why I've marked this as private set is because I actually don't want this property specifically to be changed from outside of this view model. I only want the view to be able to read whether we are isRefreshing or not. So what we want to do now is when we fetch our users, we actually want to set this to true because we are refreshing. So we'll say isRefreshing is equal to true. So now when it's true, we'll show some kind of UI on the screen to tell the user that something is going on. And then what we then want to do is after we finish getting back a response from our URL session, we'll actually set isRefreshing to false. So it'll actually be the last thing that we do. And the one thing to note as well is you want to make sure that the isRefreshing is within your dispatch queue main, because you're going to be interacting with the UI when we actually change this property back to false. So now we want to make sure that we use this isRefreshing within our view so that we can switch between our list and some kind of UI to tell you that something is going on. Now what that UI is going to be is a progress view. So let's go into our content view, and within our Z-stack I'm going to do a bit of typing and we'll break it down. So what we're simply saying here is that if our view model is refreshing, then I want you to show the progress view, or else to show this list that you can see on here with the users. And if anything goes wrong as well, what will actually happen is we'll actually show that alert within the UI. Now, it's actually possible that whilst our view is refreshing, that we actually do get an error. So realistically, the problem that we have here now is because if refreshing is equal to true, whilst we get an error, then you actually will never see the alert on the screen. So rather than the alert being attached to the list, let's actually move this out. And we're going to instead attach this onto our Z-stack. So whenever there's ever an issue, it will always appear on the Z-stack as an alert. So now what we want to do is actually test this out. So in order to actually see this in action, what I'm going to do is actually fix our URL because I broke it on purpose. So in order to actually see our progress viewer on the screen, what we need to do is actually simulate a bit of a delay because this API is really quick and my internet is quite fast as well. So rather than us doing dispatch queue main async, we're actually going to change it to async. So what this is going to do is this is actually going to add in a 1.5 second delay before we actually handle showing any of the UI on the screen. So this is just temporary, by the way, it's just to show you the progress view. So let's actually run this. And now you can see the progress spinner. And after 1.5 seconds, we now get a response back. So if something does go wrong whilst it's loading, we still get our error on the screen. But if I actually change the URL to actually get a valid list of users, since that URL was messed up by me on purpose, Now you see our progress spinner, and then now you see our users come onto the screen. So we've now got it working where if for whatever reason we have a slow network connection or the API is just taking a bit of time to respond, we have that visual cue back to the user that something is going on. So just before we wrap up, I'm actually going to take this out because we don't want a delay and just turn it back to what it was. Okay, sweet. So that's everything in this video. If you enjoyed this video, I'd really appreciate it if you left some comments in the comment section below. Also as well, if you haven't already, I'd really appreciate it if you gave the video a thumbs up, as well as subscribing to the channel and hitting the notification bell to get updates for whenever I release a new video. That's everything from me. I'll catch you on a bit. Deuces.